Alright, hi everyone. In this video we are going to continue on with slope. If you haven't seen part 1, make sure you go watch that first. But let's continue on. So next up, example 15 is going to be another example of graphing using slope. So first thing we need to do is get this into slope-intercept form. So I'm going to rewrite it down here, that way we can go ahead and solve for y. So first thing we want to do is we want to move the x away. So we're going to have 3y equals negative 4x plus 6. Next, divide both sides by 3. So we get y equals negative 4/3 x plus 2. So for our slope, it's going to be negative 4/3, and our intercept is going to be 0, 2. Alright, so again, we're going to start at the y-intercept, in this case 0, 2. And in this case, our slope is negative. So what we're going to do is I'm going to put the negative on top. Technically, this is just as correct. However, I'm putting the negative specifically on top here, just so we can easily see that it's with one of these numbers. Specifically that we don't accidentally give the negative to both. It should just go to one of these numbers. Alright, so a negative 4 would mean that we're going to go down 4 this time. Positive 3 still means right 3. So from our starting point, which is our y-intercept, we're going to go down 1, 2, 3, 4, and we're going to go right 1, 2, 3. That's our next point. To get a third point, we're just going to do it again. So down 1, 2, 3, 4, right 1, 2, 3, put our next point. Once we have that, we're just going to draw the line through our points, and we're done. Alright, example 16. Again, still have to solve for y first. So move x over. So minus 3x on both sides. We get negative y equals negative 3x plus 1. Be really careful here because we still aren't done solving for y. Negative y is not the same as y. So we have to get rid of that negative. To do that, I'm just going to divide both sides by negative 1. That turns it into positive y. And on the right side, we'll have 3x minus 1. So our slope this time is 3, and the y-intercept is 0, negative 1. Now, up until this point, our slope has been fractions. And the reason that we usually like it as a fraction is because it's specifically rise over run. So it being a fraction makes it really easy to see the rise and run. Now, anytime you have a whole number, you can easily turn it into a fraction by just putting it over 1. So anytime it's a whole number, it just means that you're going to go up or down that much and write 1. But if you need to visually see it, turn it into a fraction, then it's the exact same as all of our other ones. So we're going to start at 0, negative 1. And from there, we are going to go up 3, right 1. So up 1, 2, 3, right 1. That's our next point. Do it one more time. So up 3, right 1. That's our next point. Then we can just draw the line through those, and we're done. All right, last one for graphing using slope. So in this one, y is already solved for. So since y is already solved for, we don't have to worry about that step. Instead, we can already just go into talking about the slope and y-intercept. So the slope is just 2. Again, if you want to turn it into a fraction, make it 2 over 1. That's perfectly fine. Our y-intercept is normally the number that doesn't have x with it. But in this case, that's missing. Well, if it's missing, then that means it's actually just 0. There's nothing there. So our y-intercept in this case is 0, 0. All right, so we're going to start at 0, 0. And from there, we're going to go up 2, right 1, first point down. Again, up 2, right 1. Next one down. Oops. If I can erase just the red, there we go. And then we go ahead and draw our line through those points. All right, so now that we have a good grasp on graphing using slope, we're going to go ahead and go in the opposite direction. So this time you're given a graph, you're asked what is the equation. So remember, we've needed 2 things this whole time. We've needed the y-intercept, and we've needed the slope. And that was because our equation gave us those 2 things. So if we can just find those 2 things, we can plug it right back into the equation, and we're good to go. All right, so for this one, slope first off, if you remember the first part of the last video, you just pick any 2 points, say this one and this one. Then you count how much do you have to go up. That's 1. How much do you have to go over? That's 3, so our slope is 1 over 3. For our y-intercept, that is just going to be where it hits the y-axis. In this case, that is 0, 2. So using that 1/3 and that 2, we can plug those into our m and b, and we have our equation. So it's going to be y equals m, which was 1/3, x plus b, which was 2. All right, we're going to do the exact same thing again for the next one. So again, we're going to need slope, we're going to need y-intercept. For the slope, I'm going to pick 2 nice points. Then we start by counting how much we're going to have to go down. So 1, 2, 3, 4, 5, 6, 7, 8. And again, that was 8 down, so we're going to write it as -8. And then over 2. Now, in this case, if you notice, -8 divided by 2, that can actually reduce into -4. Now, the reason that it's going to reduce is because this time I happened to pick 2 points that weren't the 2 points that were closest together to each other. As in, there was another point right here I could have picked. And if I had picked that point and either of the other 2, then we would have gotten -4 over 1. I happened to pick 2 other points but we still got to -4 in the end. So don't worry about which 2 points you're picking. It'll still reduce into the same exact slope. All right, that said, the other thing we need is going to be the y-intercept. So it hits the y-axis right there. That is at 0, 5. So our equation then is y equals m, which is -4, x plus b, which is 5. All right. Next up, we're going to be talking about how to get the point slope form, or the equation of a line in general, given either a point and the slope or 2 points. Now, notice I said a point and the slope, as in the point that you're given may not be the y-intercept this time. If it is the y-intercept and you have the y-intercept and slope, cool, you get to use y equals mx plus b, nice and easy. If it's any other point on the line though, we are going to have a new equation. So this right here is called the point slope form of a line. And the cool thing about it is any point and a slope can give you this form. So you don't need a specific point like the y-intercept, you just need any point. So, for example 20, we do have a point, so I'm going to go ahead and label it as x1, y1. And we do have our slope, so remember that's m. So all we have to do is plug it into this equation. All right, so to plug it in, the y and x without the ones, those are going to stay variables. Those are the ones that we need for our equation to be an equation. So those are going to stay there, but the y1, x1, and the m, all of those are going to be replaced with our numbers that we have. So it's going to be y minus y1, which is 3, equals m is -3/2 times x minus x1, which is -4. Before we go any further, I am just going to go ahead and clean up that minus a negative. Remember, minus a negative really just means plus. So I'm going to do y minus 3 equals -3/2 times x plus 4. All right, this right here is the point slope form of this line. That said, from here, it depends on what the question is asking for. If it asks for the point slope form, cool, you're done. If it asks for the slope intercept form, that's the y equals mx plus b one, that one we'd have to solve for y and simplify. So just to go ahead and at least show that once to make sure that everybody's okay with it, if we wanted to go ahead and simplify this and solve for y, first thing I would do is go ahead and distribute out that fraction. So we have y minus 3 equals -3/2 times x is just -3/2 x, so that one's easy. -3/2 times 4. So you can do 4 divided by 2 is 2, times -3 is -6. Last step, if we want to solve for y, add 3, and we end up with y equals -3/2 x minus 3. And then we'd be done. All right. Again, it does depend on what the question is asking you. Some of them will ask for it in different forms. but just want to make sure that I showed how to get it into that form at least. All right, so let's do another one. Example 21. So again, it's y minus y1 equals m times x minus x1. And this is x1, y1, and m. So we're going to go ahead and plug everything in. So y minus y1, which is -1, equals m is 3/4 times x minus x1 is 8. And first thing I'm going to do, just to clean it up a little bit, minus a negative, that's really plus. So we get y plus 1 equals 3/4 times x minus 8. If you're looking for it in point slope form, you are done. If you are wanting it in slope intercept form, then distribute. So it'd be 3/4 x minus 6 if you multiply that fraction by 8. Subtract 1, and we end up with y equals 3/4 x minus 7. All right, number 22. So for this one, if you notice, it doesn't give us a slope. It gives us two different points, but it does not give us a slope this time. So we can't actually use point slope form right away. Instead, since we do need a slope to be able to do that, we are going to use the slope formula. So again, this was in part 1, so make sure to watch that if you haven't. But this is going to be x1, y1, x2, y2. And the slope formula is m equals y2 minus y1 over x2 minus x1. So if we start plugging everything in, y2 is -7, minus y1 is -1, over x2 is -10, minus x1 is 5. So again, we got a minus a negative, so it's going to be plus. So -7 plus 1 is -6, over -10 minus 5 is -15. Next up, -6 divided by -15. We can reduce that fraction at least. First off, the negatives cancel out, and both of them can be divided by 3, so we end up with 2/5. All right, now remember, we're not quite done yet here, because that's just the slope. In the end, we want the actual equation. So we can now use point slope form because we have the slope. We have more than one point, so we can actually choose. I'm just going to choose this one. So we're going to do y minus y1 equals m times x minus x1. If we plug everything in, that's going to be y minus -1 equals 2/5 times x minus 5. Minus a negative can turn into a plus. So we have y plus 1 equals 2/5 x. 2/5 times x minus 5. That's our point slope form. Again, you can go ahead and solve for y and simplify in order to get it into slope intercept form. But for this one, I'm going to go ahead and leave it here. I will give you the slope-intercept form just in case you want to see if you can do it. It's right here, so that would be our slope-intercept form. But again, to solve for it, just do the same thing as 20 and 21. All right, 23, last one of these. So again, we're given 2 points, so the first thing we're going to have to do is find the slope. So that's y2 minus y1 over x2 minus x1. I'm going to go ahead and label everything. So it's x1, y1, x2, y2. So if I plug these in, that's y2 is negative 2 minus y1 is 13 over x2 is 4 minus negative 1 for x1. Again, don't forget that's going to be a plus. So that's negative 15 over 5 or negative 3. All right, now we get to go ahead and plug it into the other formula. So y minus y1 equals m times x minus x1. If we plug everything in, we're going to have y minus 13 equals our slope, which is negative 3, times x minus x1, which is negative 1. I'm going to go ahead and fix the minus a negative. So we got y minus 13 equals negative 3x minus 3. Sorry, I am getting one step ahead of myself. Negative 3 times x plus 1. And then if we did want to go ahead and solve for y, you would end up with y equals negative 3x plus 10. Okay, last little topic. We're going to talk about some special lines. So these are lines that you won't have to graph using slope. You do already know the slope of these lines. You just don't know you do yet, because we did go over it in the first part. But these are much easier to graph. You don't need the slope. Here's what we're going to do. So x equals 7 is our first one. Anytime you have x equals a number, that is just a vertical line. To graph that vertical line, all you have to do is go over to where x equals 7 on the x-axis, and then draw the vertical line through it. It is that simple. Similarly, for y equals negative 3, y equals any number is a horizontal line. To graph it, we're going to go down to y equals negative 3 on the y-axis, and then we're just going to draw the horizontal line. So all you have to remember is that x equals a number is vertical, y equals a number is horizontal. And then they are very easy to graph. No slope needed. That said, just as a little recap, if you remember, the slope for a vertical line was undefined, and the slope for a horizontal line was 0. Alright, so let's go ahead and try these last two. For these, it's the same exact idea, and we know they're going to be special lines because there's only one variable in each. Right, so we're just going to solve for whatever variable is present and then graph that line. So in the case of 26, to solve for y, we're just going to divide by -7. And we would get y equals -2. My negative kind of blended in with my equals, so let me make that a little more pronounced. So to graph it, we're going to go down to -2 on the y-axis. Y equals is a horizontal line, so we just draw the horizontal line through it. For 27, it's going to be very similar. We're going to start by solving for x. So start by adding 10. We got 2x equals 10. Then we can divide both sides by 2, so x equals 5. Alright, so for this one, we're going to go over to 5 on the x-axis. X equals is a vertical line, so we draw the vertical line through it, and we're done. And that is all for slope and graphing lines. So make sure that you let me know if you have any questions. Otherwise, I will see you in the next notes. Bye.